Today we're going to attempt to fix this heat pump. It's an old Aqua Pro systems heat pump. I don't believe they exist anymore. And this has to be one of their first models. I think it's like 2006. It works, but the problem is when it's actually on, you cannot read anything on this display, and you can see the buttons are all kind of messed up here. I've looked online, I can't find parts for it, so instead what we're going to try to do is retrofit a different control board from a Hayward that I found online. It looks very similar. This is the kit that I ordered. Hopefully this isn't upside down. And you can see the part number right there. Now as we come over here, this is what's included. There's a board inside you haven't seen yet. There's this cable that connects everything. The part right here in my hand is a gasket for the display. I'm not sure if we're going to use that. And then the display itself is going to be in here. So you can kind of see it through there. Or it's on the other side right here. See the buttons back there. Before we work on the heat pump, I have the power turned off right there. And then we're going to verify that at the heat pump just to be absolutely sure. Now go ahead and take these screws out. You can see I took most of them out already. So all we're going to do, and this is kind of broken, I'll have to fix it later. Now, take the screws out to drop these. This phone's really kind of zoomed in. Okay. And then from there, this just kind of pops out like that. So you can see I already have it unplugged. So this is the board that's on the back. And then inside there's this second board. So we're going to replace both this board and this board with the Hayward. And the control scheme looks almost identical on the inside for the Hayward, so I think it's going to work just fine. The next thing we're going to do is we're going to check right here is the feed, the supply to the heat pump. So we're going to check that for voltage to make sure that it's off. Now my multimeter has both a non-contact voltage detector, which is what this setting is, and it also has the typical probes. But if we bring this in here, you can see it's not reading anything. If we were to bring it over to this, you'll see it's getting a reading. So now let's go ahead. I can't do this with one hand, but if I put this on this setting, this is for AC volts, I can then go ahead and just double check that there is no voltage, and take my word for it. I don't have a tripod, so unfortunately I can't show you. We have our new Hayward board right here. You can see the old board in the background. We're going to replace the two, and what I'm going to do is I'm going to move these wires over one at a time. Take a picture of this first so you know where everything goes. This actually does have a wiring diagram helpfully inside, but we're just going to go ahead and move these over one at a time. So we're going to go sensor to sensor. We're going to leave the pump EX off, the RV off, which I believe is a reversing valve, and you can't really see underneath there, but it's pump, or sorry, compressor, WP, LP, HP, and then the transformer. On the Hayward board, I believe the HT needs to be jumped. As I was going through the Hayward box, I did find the jumper in the very bottom of it, so I didn't see it originally. So that's just going to jump these two HT terminals. Another note is when you go to remove these, either use pliers or just be very careful not to grab the wire as you're pulling these off. I'm going to remove, hopefully, this. And all this is the control circuitry for the board right here. That gives me better access to these spade terminals. And we'll just move these over one by one to the new control board. I barely even touched this one. It means the contacts broke right off the board. I mean, I barely just nudged it. I didn't even pull it. So I'm actually surprised this is working, because like I said, the last time I turned it on, it actually was working and functioning, but you couldn't read the control panel at all. It looks like we have more problems, so it's a good thing we're replacing this board. Okay, everything's switched over. I don't have a ground on there. We'll see what we're going to do about that. I might try it without it first, just to see what happens. And this is all off, so now I'm just going to take the screws out, and hopefully it lines up with the connection or the holes in this board. What I noticed is we have these type of standoffs on this old board. So it's got a screw in front. Well, the way they installed these things is the screw goes completely through to a nut in the back, to another nut right there. Then it's got a little plastic spacer, and then it goes into the board. You can see one kind of taken apart right here. So the problem here is every time I take one of these out, I can hear a nut drop down to the bottom of the unit inside. It's a real pain to get to. So I think what we're going to do is just remove these old standoffs, put these plastic ones back in, and then pop it back into the unit the way that Hayward would have done it. I have 5 holes on the unit. So you can see that there's one knot drilled right here. So I left that particular standoff out. Now what we're going to try and do is just pop this in. It looks like they should line up. Do that. You can see they all kind of line up. Don't get the wires caught. This is hard to do one-handed. I don't know what you can see, but it's going in. I'm actually not going to pop this all the way in. It's just sitting here right now, and then I'll pop it in enough that it actually retains the circuit board permanently after we test everything and confirm the unit works. I moved to the shade to retrofit this control panel. So the first thing we're going to do is take these 4 screws out. And again, I'm not sure if I can do this one-handed. Let's see if that's out. These look like they're wood screws, so this is probably not done correctly, but this is not my work. Alright, so looks like the board's out. You can see there's a gasket back there. So there's this panel here. Hopefully we don't need that. See in a second. And then we've also got this zip tie here. We're gonna have to cut that zip tie. And you can see the old board. It says no VAR controls on it. These buttons, obviously we're getting weather into them because this is all broken. Here's the new Hayward. You can see it looks like they give you a variety of mounting options. There are these 4 screws here that we're not going to be using, but there's also the standoffs behind, and I just checked, it looks like they do line up. So it'll just sit in here like that. And then that black cable is going to go from here to that control board we just installed. And realistically that's about it. So this we're going to want to scrape off. I think I might actually make an entire new panel here because this one's pretty cracked up. So I might leave the gasket out for now. I'm debating that. But we want to clean this gasket off, or at least I'll install it loosely so I can reuse it. So we're going to clean this off, and we'll grab our gasket, which of course is hung up on that wire I was just talking about. So this looks like this is probably adhesive. I'm actually going to leave that on, and that just kind of sits in here between the screws. Try to get it straight so it will seal. You stick the unit on top of that, you screw it in from the front, and then we plug everything in and hopefully it will work. There's the new panel installed. You can see the gasket peeking out on the left, which is fine. I just have it installed. It's not super tight, so I can pull that gasket back out and reuse it when I go to replace this front piece. So all we're going to do, plug this all back in, put the screws back in, then we'll test it. This particular heat pump, I also just repainted this grate. And as I put it back together, these white kind of insulators for the spade terminals from the fan, it's a universal kit fan, completely split apart. So I have to go ahead and cut that zip tie, and I'm just going to electrical tape it right now so that it doesn't short out when I go to test this. But we're going to need a more permanent solution for that in the future. You can also see the screws are out to hold the actual fan in place. Alright, I did a not great job of electrical taping that, but it should work. Ran a few screws in. We're going to go ahead, go inside, turn the panel on, and we're going to see if this works. See if it sets. Alright, I already see something going on. I don't know if you can see, it's pretty dim because the sun's directly on it. That says 85. I don't know if you can see that. So 87. So it's reading the temperature. Right now this is Florida in July, so it's probably very hot in the pool. So let's go ahead and set our set point up to like 90. and see if it'll kick on. I just walked outside and literally just heard it kick on. So there you go, it's running, 87. The run light is on, if you can see that. The full light is on, everything's working exactly like we want. So I'm gonna go ahead and call this a success. We have a working Aqua Pro systems heat pump on a Hayward controller. If you like this content, please like and subscribe. I checked the water in here and the outlets are extremely warm. I also checked the power usage on this unit and it is 7,000 watts while it's running. It draws substantially more, it's like 3.5 times more than my home heat pump when it's running. So these things are expensive to run, but if you live in a little bit cooler area, it can be a very efficient way to heat your pool.